Hello, everybody. Welcome to another day here with Mo Math and MathPickle. It's so good to see you guys. And today I have a special guest, and this is him right here. Do you want to say hello? Or no? You're gonna pretty well just observe. I think is that accurate? I don't think that you really want to do anything other than just observe, right?
I don't want to observe. I want to introduce the problem.
But you don't know what the problem is because I haven't explained it to you.
I do know what's going on. This is a mini mathematical universe, and the kids have to try to guess the rules.
Oh my gosh.
No. This is just going to be too much work. I
have a question, Gord. Are you a ventriloquist, or is that?
No, I can't do this. So, you know, you're a real handful, so I won't be able to teach math and deal with you at the same time. Okay, so do you mind if you understand?
I do know what's going on.
No.
And
no.
Have to try to guess the rules.
Okay, cool.
Oh my gosh. Oh my.
Okay.
Are you good there?
Okay, bye. Go away. Okay, there we go. Okay.
I have a question.
Yes, go ahead. Question.
Are you a really good ventriloquist? Is that a recording, or is that Slappy's cousin?
I'm a terrible ventriloquist, but I thought it would just be a laugh. So, so we are going to be doing a mini mathematical universe, and the point of this for you guys is to figure out what is going on. So here is, do you guys see my screen?
No, we do not.
Okay, here we go. There we go. So there is my screen.
Is this the mini mathematical universe?
That's right. You guys wake up one morning and you are on this weird grid and you are asked to put in some numbers into this grid. So I'm going to start with you, Angie. Angie, choose a number that you would like to have in this first square here. Any number that's
25.
25, okay. 25. There we go. And another number, let's go with Kestrel. Go ahead. What number would you like here, Kestrel?
7.
7. Okay. You can make the numbers big, like they don't have to be small. Ayan.
14.
14. Okay. You guys can stop annotating what's happening. Do you know why? Because nobody knows what the heck is happening. This is a mini mathematical universe, and
You know.
I know what's going on, but you guys don't. And so what's going to happen is that you guys are going to be poking around, trying to understand what's going on in this mini mathematical universe. You can name any number here from anywhere from 0 to like 600, let's say. Ananaya, hello. You can name any number between 0 and 600. Nobody knows what's going on. Go ahead. What number would you like?
Excuse me, are you talking to me?
Yeah. Oh, no. Ananaya.
Thank you. I'll take
What?
527.
527. Okay. And Seth, go ahead. Any number between 0 and 600. Go ahead.
0 and 600. Okay. 599.
599. Okay. Well, maybe you could go a bit above 600. I don't mind. Elena. Helena, go ahead. I think that you're there somewhere. Okay, Zuko, go ahead. Zuko, you are muted. So I don't hear.
Okay.
Yeah,
Can you hear me well?
Now I can hear you perfectly well, Zuko. Go ahead. And any number between 0 and 650, something like that.
600
problem.
between 650 and
Any number. Okay,
I'm gonna say 29.
29. Got it. Okay. Avocado cream. Go ahead. Any number?
That's totally a thinking face. Just let's see here. Just think of a random number because we don't know what's going on.
Quickly.
Oh, okay.
We're not gradually thinking of it. You can think quicker than that. So go ahead.
Gosh.
512.
You need to just like
Okay,
open up some
Next
random.
person. I'm gonna go to Valentina.
Wait.
Valentina.
And right when I think of the number.
Valentina, go ahead.
Okay. After them, can I go? Because I thought of my number.
Okay. Valentina, your turn. Okay, let's Oscar, and then we will go to avocado cream. Go ahead, Oscar.
143.
143. Okay. And lastly, avocado cream, your number?
200.
200. Okay. So this is a mini mathematical universe. You guys have no idea what's going on, but you've input these numbers and guess what happens? Nothing happens.
Wow.
Wow, what an exciting mini mathematical universe it is. Nothing happens.
What
Okay.
if we try putting in consecutive numbers or all primes?
Okay, you could try that and nothing would happen.
Powers of 2.
Okay? But you notice that there's two little switches here. So that's I'm not saying anything more. I'm just saying there are two little itsy bitsy little switches here that you can hardly see, like they're really small, but they're there. There's a red one and then there's this green one. Solly, it's your turn to choose what you want to do in this mini mathematical universe that you wake up one morning, you've got no idea what's going on.
So I can do anything?
Yeah, you can do anything. And I'll tell you what happens.
Let's click 14M.
Okay, but I'll give you a clue. To make something exciting happen, you probably want to play around with these colors.
Okay, flip the green switch.
Okay, if you flip the green switch, then all of these turn to a beautiful green color like that.
Perfect.
So someone has annotated right on our screen. I'm going to have to remove the annotation. Yeah.
Well, I could not chat.
Okay, that's okay. I understand. So can you remove that now, but because now you can.
Sure.
Thank you.
Consecutive numbers, like I said earlier.
Okay, so this does work, and it produces this result here. Here we go. It produces that.
Whoa.
Okay.
Was this made pre-hand?
No, you guys. This is what you guys have created. So these numbers that you inputted, they created this. But from here on, you get the feeling like these ones didn't matter. So what will I do? I'll make them I'll make them a different shade of green. I'll make them kind of a lighter green. So these ones didn't count, but the first ones did count. Okay. So you guys have to figure out what's going on. I'm not telling you. And we will go to Oscar. What would you like to do? You're trying to figure out the rules of this universe. I'm actually just going to erase these numbers. No, I don't have to erase them. If you want to use them again, you could.
Maybe you should put, just a suggestion, maybe you should put the numbers that don't have, in like a list so that I'll know which ones don't work.
Okay. So that's great. So I like that. So Oscar's suggestion is that we are going to be making a list of numbers that don't work. So I'm going to put that, let me go to a new slide. And yeah, I just have to get rid of this background here. Let's go with this and go with blank. Okay, there we go. So these are the numbers that this is Oscar's list, and I can come back to that. You can add numbers that don't work. There we go. Okay, Oscar. So where would you like to explore? That was a good. Where would you like to explore?
Here's what numbers I'd like to do. I'd like to do 85.
Yeah.
24.
Yeah.
129.
129. Okay. 129.
47.
47.
2.
2. Okay. 2. Yeah.
212.
212.
347.
247. Okay.
And 215.
215. Okay. So, whenever you do that, does somebody want to guess what is going to happen?
I think I know.
Yeah, go ahead.
Absolutely nothing.
Absolutely nothing is the correct answer. Absolutely nothing happens. So this is a kind of a, yeah.
I wonder what happens if we press the red button, because I mean, like we pressed the green button and then it turned green, but it's already red. So what would happen if we touched the red button?
If you touch the red button, it stays exactly the same and nothing happens. So,
oh, that's so exciting.
yeah, it's very exciting. And this one fails to do anything for these ones. So I'm going to color those ones light. Oh, sorry. Assuming that you go ahead. I didn't do that. Okay. Go ahead. What would you like to do, Seth? Tell me what you want to do with these.
Okay, press the green button and then eliminate the last two because apparently the last two didn't work.
Yeah, so the last two didn't work, but the other ones did. Let me color them like that. And these ones I'm just going to color a lighter color, and I will transfer them into Oscar's page of ones that failed. And
I have made an observation.
Okay, there we go. And now I am going to show you what you get whenever you do this.
The only ones so far to be eliminated have been at the end.
Okay, this is what you guys get whenever you perform 85, followed by 24, followed by 129, 47, 2, 212. And then these ones, you got the feeling like it just failed at these ones. But this is the pattern that you get. Okay. Stick person, what are you thinking of this?
Maybe it has something to do with the area.
Maybe something to do with the area?
Mhm.
Yeah, I have an idea for.
We could call this the, okay, please remove the annotation.
Okay, I will. Just in a sec.
Okay. So,
Wait, I can't erase it.
okay, I'm going to erase it. That's fine.
That's clear.
And here we go. There we go.
Puzzlecat's wallpaper looks really cute.
So this was a conjecture that something to do with area.
Uh-oh, it's going off screen.
Oh, thank you. And this was Taco Cat's conjecture.
Didn't I come up with it?
Who came up with it? Oh, stick person.
Stick person.
Sorry. Stick person.
Yeah.
There you go. It's a stick person conjecture. There we go. Okay. So something to do with area. Now, Angie, this looks difficult. Like if I were you, I would just be going, I have no idea what's going on here. Like no idea. How are you guys going to tackle this universe? You want to figure out what's going on. Do you have any idea how to approach this in a different way? So Oscar's idea was 85, 24, 129, 47, 347, 215.
How about we change one number and then see how much that makes a difference?
Okay, so Seth, I would like this way of exploring the universe. So it's really complex. Your idea, change one number. Okay, which one number would you like to change?
Could we change 85 to 84?
5 to 84, absolutely.
No.
And if you do that, I will tell you that your result is this here.
Oh, it does almost the exact same thing.
So here is the 85 answer. Here is the 84 answer. Okay, so Seth, this was really, really nice scientific exploration. This is exactly what scientists do. They keep everything else fixed. They change one variable. Very good thinking. Okay, Solly, go ahead. Tell me about how you would like to explore this universe more.
I would like to note that it probably has something to do with the numbers and letters.
Okay, so this is Solly's conjecture. Solly's conjecture, something to do with numbers and letters. Okay.
And it went off screen.
And
I have
maybe
the
something to do with going off the screen as well.
And
Maya,
also, I want to try some numbers.
Okay, go ahead. Tell me, so you're going to be starting from scratch?
Yeah.
Okay.
1, 3, 5, 7, 9, 11, 13, 15.
1, 3, 5, 7, 9,
Yeah, something to do with primes.
11, 13, like that?
15.
15. Okay.
It's adding
15's not a
2.
prime.
Okay.
And this is just odd numbers.
Oh wait, you're doing odd numbers. Thought you were doing primes for some.
Okay.
9 is not prime.
It'll just be a second till I construct your solution, Solly.
Yeah.
And at the start, I'm assuming that it does absolutely nothing because that's usually what it does.
Yeah, so following the idea about turning things green, if you would like to do that. Oops, no, I don't want to do that. I can turn things green and there we go. Okay.
Perfect.
If you do that, then this is the result that you get right here.
Oh my goodness.
Okay, so that is symmetrical.
Oh, it's highly symmetrical. Again, Solly, This was good scientific thinking. Put in a pattern.
But the thing is,
Nothing about this universe. You put in a pattern that you understand, and you got out something that has got a lot of pattern to it.
I have an idea.
What's your idea? Go ahead.
You know, the first bar is 1 away from the beginning,
Yeah.
and the second one, which is 3, is 3 away from the beginning. And the third one, which is 5, is 5 away from the beginning.
Yeah.
And it just keeps going like that.
Okay. Okay.
I think I know.
Taco Cat, you want to come up with an idea?
A conjecture, but could I first please see the last two that we had?
There's 4. There's 85.
I think it might have something to do with the numbers, that a certain area of numbers, like a certain range of numbers, will be the ABC. A certain range of numbers will be the 1, 2, 3. And I've noticed that usually there's the same number of lines as there are numbers that played a role in the creating of the.
I think it's time for a poll soon.
Oh,
Yeah.
Thank you, Solly. Thank you. Okay. Yes, I think you're right. Here is a poll right now.
Perfect.
So this is great. This helps MoMath figure out how many people are here and how many people are watching. So enjoy filling that out.
This
Enjoy pressing 2 buttons.
And you've got
yep.
and oh, still people putting in and finished. And
Is it just me, or does this one look like a parking lot?
Wait, I noticed something.
yes, Seth. That's Seth?
No, in this one, I think this, remember how in the odd number one, the lines were a certain distance away that we thought might be determined by the odd numbers? And this one, well, in the one we were just at before the odd number ones, there was a 2 and there was line 2 away from it. Yeah.
So this is strengthening the conjecture that there's something about the distance here from this edge.
So, can we try changing that 2 to a 3 and see what happens?
This one here to a 3?
Yeah.
Okay, and if you do that, you are correct. This goes over here.
Okay, so it does have something to do with the numbers from the top and from the edge. But if we we're inputting really high numbers. So I wonder how that works.
I have another idea. I just want to see something really quickly. Could you change that? Could you change that 212 to 211?
211, and that is going to do this.
Okay, I have an idea. So I think that in a certain number range, it goes, well, that decides the numbers, and then in the next number range that decides the letters, and then the next number range that decides the numbers, and then in the next number range that decides the letters, and so on and so on.
Okay. So
only 25 squares.
Zach?
Why is the side length of the big square 25?
Rohan has noticed that the side length is 25. Yeah. So what's your idea, Rohan? Why 25? Any ideas?
No, I'm not sure. But I think it's because like 25 squared is it 625?
Yeah, it is.
Oh, okay.
Yeah.
So maybe it's because of that.
Yeah, and you notice that whenever I was introducing this, I said, oh, maybe choose numbers 600 or less. But of course, this is for ages 8+. So they won't know about square numbers and stuff like that. So you won't need to get into that to figure out what the heck is going on here.
Okay.
Yeah, but it's great, Rohan, and you know, I might be presenting this later on, or maybe I'll present it with other kids, older kids. Zuko. Okay, Zuko, and then I'll go to Taco Cat. Zuko, go ahead.
So pick which number it is.
Any
number?
No, it's so this is where we are exploring this universe, Zuko. We've found that if you input a very regular pattern up here, like Solly did, you get a very regular pattern out. You also saw people play around with where these, with the 211, 212, and saw how those modified. So people are gaining some understanding about what's going on, but I don't think you understand everything that's going on.
Maybe if you go over 25, it's kind of modular.
Yeah.
Right.
Okay.
I have an idea. Can we go back for a second to the one with a bunch of random numbers?
Random numbers. So this is Oscar's random number generator.
Can we change that 24 to a 26?
24 to a 26. Okay. And this is gone. And actually, I'm going to have to do a little bit of work here. Just a second.
Yep, that's proving.
I want to see if this proves my hypothesis. Well, if this gives more evidence towards my hypothesis.
Yeah, it seems like it.
I have an idea.
Because if this has to change to if this has to move 45 out of 45 degrees.
I'm nearly ready. I'm going to remove this and I will show you guys the new result that you get whenever you input that new set of numbers. And this is what you get. Okay, so before you got this one, 8424, and I.
It's almost as if you just shifted the whole thing up.
Yeah.
But the gap got wider though. Excuse me.
This is changing two things. It's changing the. Let me change back the 85 to an 84 here, because that might be a little bit confusing. So there's the 84. Okay, there we go. So this is the 84. So now these ones are identical, except that for the 26 and the 24.
Can I try something else?
That's not true. I guess there's 2 and 3 is also changing. Go ahead, Seth.
Okay, could we switch the 84 and the 24? Possibly. I just want to see if slots, like which slot the numbers and holds any value.
Okay, let's do that. So I am just going to trade those ones. This is 24, this is 84. And I'm ready. Seth, thank you. That was great improvising.
That was all
Not
4
improvising.
words.
It's from the Canterbury Tales.
Okay.
By Geoffrey Chaucer.
Okay.
Thank you.
So
Okay, there we go. That is what you get.
Number gen, and I want to see what happens if we do a random number.
So the slot does matter. I'm okay. So
Okay, so you guys, this one here is right. Okay. This is 8424, and this is 2484.
Okay.
So that was also great to experiment with switching to understand what the heck's going on. Well, just shift 2 of them and see if you can figure out from that.
I just understood something. If you noticed in the 8424, we had the lower one like that, and we basically just rotated it. and we just found out how long those thingies that are coming out, those two thingies are. And they went into that thing, which does kind of mean that the slots matter. And as I said, they're alternating.
So it's hard to explain what's going on. Like here.
Are you sure this is 8 plus?
Yeah, I maybe I got this one wrong. I think I did.
Could I try something else?
Yeah.
Okay. So could we just put 0 on everything?
0 on everything. Okay, absolutely. Great idea. So
and then I'm gonna first I just want to see what that looks like. And then I want to put 1 in the first slot after that.
Okay.
I bet.
So if you put 0 in everything, do you want to take a guess? How many people want to guess what happens here?
I'm gonna
say nothing happens at all.
Yeah,
I'm
nothing.
gonna say,
I say
that
everything happens.
absolutely nothing.
Everything.
Okay.
I
So
think I understood something.
what happens is that you get this here,
Oh,
and
that happens.
none of these work. So
well then.
Okay, so but the thing is, it's 0 from the edge.
So I'm adding these to Oscar's ones of numbers that don't work.
Okay, new idea. What if for each slot it has to be past a certain number? Can we try putting 5 in the second slot?
We can try putting 5 in the second slot. If you do that, you will get this here.
Yeah, I think I know what is happening.
Okay.
Angie,
I'm going to ask Angie to jump in here, and then Ananaya, and just go through and tell me what you're thinking about what's going on. And yeah, you can add in numbers one at a time, and that's maybe more useful than adding them on all at once. So Angie, tell me about what number you would like to add on here, and I'm just gonna add that single number on, rather than give all 8 numbers, which is hard to figure out, because then you're dealing with 8 different numbers. I'm just going to do one at a time. So go ahead, Angie. Tell me what number you'd like to experiment with here.
5.
5 again. So if you put in 5 again, this doesn't work. The 5 doesn't work. So you've got 0, 5, 5. The second 5 doesn't work.
I
have a hypothesis.
Okay, but I'm going to go to Ananaya first. Go ahead, Ananaya. Tell me about what you'd like to experiment with. And we'll just do a single number.
How about 5, 5, just all 5s.
All 5s. 5, 5, 5. 5,500, 555. How about that?
because it
No,
and
1 5 for each.
Okay, 1 5 for each of them. Okay.
That's not going to work for most of them.
So
It's not
this
gonna work.
also this also fails, Ananaya. So that's a great way to experiment. We've reinforced that whenever you have
I have an
something.
idea for an experiment.
I have a hypothesis.
I think I know.
Me too.
So Ananaya, I'm going to go to Ananaya first. Ananaya, what's your hypothesis for what's going on? The first 5 worked, but then from then on the 5s didn't work, and the first 0 worked, but then from then on the 0s didn't work. What's your hypothesis? So Ananaya, what's your hypothesis about what's going on? Why are these numbers not working?
You said this didn't have anything to do with exponents, right?
What I said is that I meant, when I created this puzzle today, and I meant it to be for ages 8 plus. So I'm unconvinced now. I might have made it. This is challenging. So go ahead.
Excuse me.
Kestrel, do you want to jump in? And
You said it.
What? I'm away. I'll be grabbing some Lotus cookies.
Actually, can I try something?
Okay.
I have a
Seth and then
hypothesis.
a Rohan, if you can jump in, a Rohan after
Okay,
Seth.
I want to see
Yeah.
if there is. Well, actually, just change that 5 to a 4. I want to see if it's invalid.
Okay.
No. The second 5.
Okay.
Yeah.
Yeah.
Change, the second 5 out of.
Oh, this one. This one.
No, the one before that. The one before that.
This one.
Yeah.
Okay. So it's like this.
I want to see if that
What
still
happens there?
works.
Okay. So this works then. And this is what you get then. You get that.
I'm getting it. I got it.
Could I state my hypothesis?
Seth, your hypothesis, and then a Rohan.
That was talking.
Oh, sorry.
Um,
A Rohan.
Slow down. I'm gonna go.
Okay. So I think that if you just look at the numbers from 0 to 24, and you put a 0 in, then that will make all of the column A black. So
Yeah. So if I was to put in the numbers 0 through 24, the whole thing would turn black.
Yeah.
Correct.
okay.
Okay. This would be the result if you put in 0 to 24, a Rohan. So you understand a little bit of this universe. I can tell you right now. You understand something about
Could I
what's
state
going on.
my hypothesis?
Okay.
and I
Rohan,
think
keep on going. Keep on going, Rohan. What else would
and
you
I
like to
think if the
experiment?
numbers get greater than 24, you use the rows.
Sorry, what happens with greater than 24?
Well, maybe I'm not entirely sure, but I
Okay.
think if you do 25, the row 1 will turn black. Maybe you can just try that.
If I try that, you are correct. The first row turns black.
I know it works.
Keep going,
Confirmed.
Rohan. Keep going.
Slots affect other slots' abilities to be useful.
So Rohan, tell me about what else you're thinking about.
Why don't you try 50?
50? So
Yeah.
if I did 50, I would
Invisible?
get this.
Oh,
Okay.
I know what's happening.
and also I've noticed one more thing, that you can't repeat numbers.
Yeah, you can't repeat numbers. Yeah.
I want to try something with the board thing.
Go ahead, avocado cream.
Okay, so I want it to be like an empty board because I have an idea for like all the numbers.
Okay, empty
It's
board
gonna
it
be
is.
the most basic one, the most basic pattern you could do, but I'm still gonna do it anyway.
Please do.
So 1, 2, however many squares, like 1, 2, 3, 4, 5, 6, 7, 8.
Oh, okay.
I'm guessing that it'll do something weird. And what I mean by weird is
I think
a pattern.
Okay. So whenever you go from 1 to 8, then you get to go up to here. Okay.
Perfect.
No, sorry. That is 1 to 8 there.
Perfect.
Okay. Yeah. Ian, your turn.
is it my turn?
Ian's turn. Yeah.
First of all, can you turn on annotate?
I can. Yeah.
Okay, where's the annotate?
Probably working on it.
There now. You're ready to go.
Okay, so I've proposed a theorem. if you use more than 5 numbers that are over 50, you will end up with something that looks a little bit like some random thing like this, leaving what seems to be a road like this. So the
Okay. Please, so please pursue that idea. I
know
like your
exactly
idea.
what's happening.
I want you to pursue it. I want you to give specific numbers, Ian. I want you to give specific numbers to create, let's say this here. I will make a diagram, and then I want you to create, let's just go like this.
I think we're out of time.
hopefully this won't take me 10 minutes to find out how to create
Okay.
it.
Yeah, hopefully not.
Okay, I'm going to ask you to create this diagram, Ian. And here we go. How many numbers? First of all, how many numbers will it take you to make this diagram? And secondly, can you give me those numbers?
Okay, excuse me for a
We are going to
second.
go a little bit over time today. So if you guys are okay with that, that's good with me. So we're going to be about 10 more minutes.
I think if you
What's
put
11 times 26?
I think if you put 10 as one of the numbers.
Wait. What is 11 times 26? What's 11 times?
Remember, this is for age 8+ students, so you don't need to have multiplication.
Excuse me. What is 11 times 26?
286.
Wait a sec.
Thank you. Okay, so 200. So we put in 286, or if that's not correct.
That's not correct. I will show you what 286 in the first row means. 286 in the first row would mean that in the first one would mean that you get this.
Then I must have.
Okay, so can anyone else maybe take 20 seconds?
I know what's happening.
Can you think of how to get this K, this column in K? So everyone
11.
think about how to get that column in K.
11.
Wait. 10.
10 is correct. Okay.
Yay.
Yeah, 10 is correct.
10. It's 10.
Yeah. Can you think of something else? Oscar, can you think of another number that you can add to get this column here?
20 will work in order to get the U.
Yeah, 20 will work for the U, correct? That leaves this one here. Any ideas, anybody? What the heck?
I think I might know.
What?
I think I might know.
Okay, who is
Did
sticking?
somebody
Go
say
ahead.
what the
I have an
heck?
idea. I have an idea as well.
Put in 31.
Oh, that's it.
30
I'm leaving if there's
31 gives you this.
Okay,
Yeah, it's
30.
30 because you want it to. Well, it's 30. It's 30. You gotta put in 30.
30.
10,
Right.
20, 30.
It's 30. So this is 10, 20, 30. That's the diagram for 10, 20, 30.
I think
I
I
think
get it.
we figured out your algorithm.
So the
I will tell you one more thing. Yes, I will. Okay, I'm going to show you one more thing. I'm going to give you, if you did this. Oh, sorry. This is 10, 20, 30. This is all green. Okay, there we go. It's all green. Boom. Okay, that's 10, 20, 30 with all green. But what happens if you did this with red? Well, if you did red, this is the result here.
I have no idea how that works.
Okay, so that's okay. You guys are it's good. You guys are at this, have figured out how to create this. So this mini mathematical universe was challenging. Okay, it was more challenging than I thought it was going to be. And it's hard to create these, like whenever you're creating these, like you know the rules. So you're creating these and you're thinking, oh, I think that's not going to be too hard. But actually this was pretty tough.
Wow.
So now what I'm going to do, if you guys want, is I'm going to show you my screen. You have seen what you guys worked on. Now I'm going to show you my screen, if you like that idea.
Yes.
Okay, sure.
You want to see? Okay, I will show you what I was working on. So here we go. Oh, you can take away the annotation. Well, actually, it won't make any difference because I'm going to switch the screen over. I'm going to move you over to my view. This was my view of the same puzzle.
Oh my
Okay.
goodness.
So whenever you guys were to just let's remove that annotation. There we go.
The gaps were.
Okay, so whenever you guys were to jump in, let's just get rid of that. Whenever you guys were to jump in here and say, what was the first one? The first one had, oh, give me some numbers. Angie, give me some numbers.
10.
10. Okay, so if you said 10, I would immediately go down here. I draw this all the way down. Okay, next, Angie, go ahead.
30.
30. So I would immediately go over to 30. I would draw this all the way over, and I would stop at this line.
Oh, I got it. I got the puzzle.
Oscar, go ahead.
Me too. Yeah.
Oscar, name anything that you want, Oscar. Any number?
57.
57. 57 is down here. I go all the way up to here. Not all the way to the top, just till that line. Taco Cat.
RNG here.
Taco Cat, go ahead. Tell me a number.
57.
57, and it stops. Okay, so you can't get duplicates. And yeah, so 57, stop it. Seth, go ahead.
Okay, so I guess it's figured out. I think everyone has probably figured it out by now. So you put in a random, you put in a number and then that creates a line. And then the next number, if that intersects, it will just stop there instead of going through. And then with the next number, if that hits another line, then that will stop there.
How do we secure
So it's like the further down the line of numbers, the less power something holds to be not stopped by another number.
Tell me what happens. Solly, can you tell me what happens if I did an 86 right now? What would happen?
It would. Okay, it would go something like.
So Ian and
this.
Yeah. Okay, so you're half right, but the answer is this here.
Why? Is it?
Okay.
Is it like green?
It needs to start on both sides, right? Wait.
Yeah, I think it does.
It needs to start on both sides if there's two lines.
Okay.
If there's only one line, it only starts on
Wait, I
one
have
side.
an idea. I have an idea.
Stick person, go ahead.
Maybe hitting another line flips whether it's shown or hidden.
Okay, test that hypothesis, stick person. So stick person has an idea that every time you hit a line, you flip on or off. Go ahead.
So,
Okay, I believe that
maybe
idea.
put in 61.
What do you expect to happen whenever I play 61? What do you think is going to happen?
It's just gonna go there, but I'm trying to get 3 lines
Uh-huh.
in a row
Got
so
it?
that now
Okay,
we can
yeah.
do
I think this
91.
is
Okay, so
his
we're going to stick
old
with stick
idea
person
for
here.
this puzzle. So
Stick person.
we've already
91.
It's stick person.
understood it.
Okay, so stick person, go ahead.
91.
91. And what do you expect to happen?
Probably go there, stop, and then resume at 14, and then stop.
Exactly right. Okay, so
I got
what we
everything.
have here is 61 followed by 91.
Person's hypothesis is correct.
What would happen if instead of this being green, this was red? What would happen? Any ideas?
Probably the ones in that long that didn't get
Yeah,
that weren't
that's
there would.
exactly right. Exactly right. So this shifts it over. You start in the off position, and then you go, and then you alternate. So this was how we were constructing these. And what do you think? What age group should I be presenting this to next time?
Maybe you should present it to 56s.
56-year-olds. The other thing I could do. The other thing I could do is I could present it to you guys, but show this diagram instead. But that's kind of losing stuff.
Okay, so can you please clear everything? Think I want to show everybody something.
Maybe you could do that same thing that
I
with
continue my
grandma.
Okay, so do 98.
Okay. Last thing, and then we're going to go for today. Go ahead.
Of physics with his
98.
and sphere halfway hold and head the down to go.
Okay. Thank you, Seth. Bye-bye.
Wait, I want to show everybody something. Do 98, do 10, and do 74.
98.
10,
then 10, then 74. Okay, there we go.
Okay, do 58, do 20, and
Okay,
then
wait,
do
58,
28.
58 is here. Okay, 58. Now 28.
Yes.
28.
Turn
Okay.
it off.
And then it goes over here and it's off the page. So that's good. It stops there.
Okay.
Okay.
Do 53.
53. So 53 is here.
There.
And that is going to color in this part as well.
64.
So you guys, I think you guys understand now a
And
lot.
96.
Oh, 64 fails. Why does 64 fail?
Oh, because this is over here. So meaning that this can go. Turn 10 off.
Yeah, you already did 10. That's why 64 is failing. You can never hit the same row or column twice.
You want to do
That's it, you guys. And for those of you who think that this should only be for 56-year-olds plus, thanks for hanging in. Take care, everyone. See you tomorrow.
56. This.
Bye.
Bye.
Bye-bye.
This.